Hello, dear students. In this video, we are going to see about the introduction about the second phase of the compiler. We all know the first phase of the compiler is lexical analyzer. Uh, Lexical analyzer will give tokens as an output. So the job of the lexical analyzer is tokenization. So when a raw high-level language is given as an input to the lexical analyzer, it will find all the tokens, so that will be the input to this second phase of the compiler, that is syntax analyzer. So syntax analyzer is the second phase of the compiler. Syntax analyzer can also be called as parsing. So actually, what is the main role of the syntax analyzer is to find the syntactic error in your program. So when a sequence of when a sequence of tokens are given as an input, for example, when we say input can be mostly used, input is positions equal to initial plus rate into 60. Consider this as a input from a high-level language. And then, this high-level language is converted into tokens, maybe like this ID1. So first question is an identifier. Then initial is also an identifier. And then plus is an operator. And then rate is an identifier, which can be, say, ID3 into 60. So three identifiers and equal to plus, and this are all the operators, and then we have a number 60. So we have a sequence of tokens now. This sequence of tokens, which was identified by the lexical analyzer, is given as an input to this syntax analysis, also called as parsing, which is the second phase of your compiler. So this will find is there is any syntactic mistake in this sequence of tokens. So this is a sequence of tokens. If there is any syntactic mistake, it will find out. So how does it find the mistake or the syntactical error is? For that, we have context-free grammar, also called as DNF. So this context-free grammar frame the rules of the particular language. So by this context-free grammar, for example, what is the rule? If it is an expression, how does it look like? For example, if I want to write an expression A equal to B plus C. So this is a correct syntax. Instead of this, if I write A equal to B plus, this is not syntactically correct, right? So this kind of mistakes can be found through this context-free grammar. So the context-free grammar will be written in the form of productions that we will be discussing after this. So by this context-free grammar, we can find, which is a rule, right? For a programming language, we can find if there is any mistake. So what is actually this parsing is doing is, parsing is going to process the sequence of token, and it is going to check whether it is following all the grammatical rule of the programming language. So that is the actual meaning of parsing. So parsing will be going through the sequence of token as we see here, this token, and it will check is it properly following the rules of the particular programming language. So this process, we call it as parsing. So how does we do? How we will we check whether this is it following the rules of the programming language? That is through this context-free grammar. So here is an example of a context-free grammar, which is the rule. For example, if I want to generate, I want to find all the patterns of this kind, then what is the context-free grammar? The rules to generate this pattern is this. So this is a context-free grammar looks like. And this we call it as a number of productions, which says a context-free grammar. And so, for example, so what are the strings which can be generated out of this context-free grammar? We can say, so S is the starting symbol here. So always it will start with the productions derived from S. So S will be either starting with A, or it can be starting with small letter b and then a. So, so first, if we go for this production, so a is this s derives, small a and capital A. So A is the terminal we'll be discussing. So followed by capital A. So capital A is a non-terminal which have all these options. So I can go for any one of this. So further for capital A, if I again use this first protection. So again I'll write A. And then after this, again, I have a non-terminal. So this non-terminal can be written as BA. And then again, AAB. And again, this non-terminal can also be written as 0A. And now this non-terminal I can again write as AAB 0, and instead of this A now I can replace with epsilon. So E means epsilon, which means empty. So now this is what the string which is generated from this from this context-free grammar, from this rule. So that is what written as a regular expression here. So you can see if you check this regular expression, I can generate this kind of pattern from this. So from this A and B, I can generate A. From this, I can again generate A. So likewise, and followed by this B can be there. And so if you take all the different kinds of combinations, I'll get one of this. Okay, so now as I told you, what is the role of a parser? So lexical analysis is giving token as an output that is fed into the parser. So as I told you, parsing is whether the sequence of tokens is following the rules of a particular programming language is happening here. And then it will produce the parse tree. And parse tree is a graphical structure of this derivation. And then that parse tree is given as an input to the rest of the phase of the front end. The next phase of the compiler. After syntax analysis, we have semantic analyzer. And in all phases of the compiler, we know that symbol table will be used, and the symbol table will be having all the information about our programming language. Okay. So what is the important role of a parser? It will find if there is any syntactical error in our sequence of tokens. If it's so, it will report. And it may be also be corrected. So there are three types of parsers available. Parser can also be called as syntax analysis, right? The second phase of the compiler. So there are three types of parser available. The first one is universal, and second one is top-down parser, and the third one is bottom-up parser. So this universal parser is not so efficient, so we are not using. And the other two parsers are top-down parser and bottom-up parser. So top-down parser, what is a top-down parser? For example, you know that all the rules of a particular programming language can be written in a in the form of context-free grammar. So the grammar looks like, let me take a grammar. For example, there is a grammar like S introduce yes plus yes star, or it can be. So consider this is a context-free grammar. It's a rule, okay, for a particular expression or for a statement or whatever it may be. So what happened in the top-down parsing is, top-down parsing is from the top. So let us take from the root. It starts from the root and then it goes to the string, the output. So for example, if the root here I starts with, so this is the productions of the context-free grammar. So if I start with yes, the starting symbol, and then this yes can be again derived into yes, yes, less. And then this yes can also be again derived into yes, yes, and then this multiplication from this production. And then, all the s can be of small a, which is a terminal. So what is the string generated out of this is a star plus. So you can understand now what happened here. I starts from the root, and then I went to the string which I want to generate. So step by step. So this is top-down parsing. What is bottom-up parsing means? What is bottom-up parsing? So from the leaf node, I will work out and then I'll reach the root. Then it is bottom-up parsing. So these are the two types of parsers mostly we are using. So so we'll discuss one by one. And in this top-down parsing and bottom-up parsing, we have many different algorithms available to do this top-down parsing and bottom-up parsing. Don't forget, what is the main intention of all this parsing is to find if there is any grammatical or syntactical error in the sequence of tokens. So for that only we are using parsing to find this error. This parse tree will be helping. So we can easily find when we convert this into a tree structure, it is easy for us to identify the errors so that we are, and that syntax tree or this parse tree, the parse tree, syntax tree, all are same. And when we pass this parse tree to the next phase, it is easy for the process. So that's the reason why we convert into a parse tree. So we have seen two types of parsing. One is top-down approach, another one is bottom. LL parser is a top-down parser. Okay, it's a kind of top-down parser. So top-down, what is an expansion of LL means? It starts from left to right scanning and it will do the leftmost derivation. To make you this understand, let me take another example. What is left to right scanning and what is leftmost derivation? That is LL. This first L stands for left to right scanning. And then the second L stands for leftmost derivation. Let me take an grammar as I took already. Same grammar I am taking. SES plus this one production. Other production is SES star and A. Okay, this is what my grammar is. And from this grammar, I want to derive a string AA plus A star. So whenever I scan, so this is what the string I want to generate from this grammar. So always start from the start string. So here we have only one non-terminal. And so I'm going to start from that. So we have so many options here. So let me start with I have three options for this root node. One is SES plus, other one is SES star, other one is A. So let me start from the second production. Yes, star. Okay, so and so LL parsing means I said I have to scan the input from left to right. So that is what left to right. And then what is leftmost derivation is, say I'm going to take the leftmost non-terminal and I'm going to derive it. That is what leftmost. So what is the leftmost non-terminal here? This S. I'm going to derive it. So what I'll do, I'll convert this S to the first production. So what will I get? Yes, plus, and then the remaining. Yes, star. Okay, so always I start to derive the leftmost non-terminal. What is the next leftmost non-terminal? This is the next leftmost non-terminal, right? So what will I do? I'll change this S to the third production. So S is also a small a. So I'll change this as A, S, plus the remaining, all I'm writing. Okay, what is the next leftmost non-terminal? This S. So again, I'm going to derive it as A. And for this, yes, I'm going to replace it with A, small a. Then plus, then the remaining as it is. Then what is the next leftmost non-terminal? We'll discuss what is terminal or non-terminal. So now next one is, see, which cannot be further divided as terminal, which can be further derived as non-terminal. So plus cannot be further derived, right? So that is terminal. But this capital S can be further derived into all these three options. So that is why we call it as non-terminal. So what is the next? Only one non-terminal leftmost is. So now this S I'm going to write as, see, actually I want this string, right? So if I want this string as an input, then this S I can write as a small star. So finally I got this string. Right. So whenever from this grammar, whenever I'm deriving a string, I'm always trying to replace the leftmost non-terminal. So it is called as leftmost derivations. So what happened in the LR parsing means LR parsing will be L is left to right scanning, same as LL, the first L here. What is right means rightmost derivation in reverse. So this LL parser is a top-down parser. Okay, and this LR parser is a bottom-up parser. So already I have told you what is top-down and what is bottom-up. So bottom-up means from the string, this is the out string. From the string, it will go to the root node. So then it is bottom-up. So that is why we called it as rightmost derivation in reverse. We are going from the reverse, right? So that is why it is called as rightmost derivation. So from the reverse. So I hope you can understand. So what happened in the same thing if I do the rightmost derivation for the same string, what I'll do, let me take the same thing. Yes, derive. Yes. So in same input I'm taking. So this time, since it is a rightmost derivation, I'll take the rightmost non-terminal. So this is the rightmost. Earlier we took this one, right? Earlier we took this one. Since it is a rightmost derivation, I am going to take the rightmost non-terminal and I'm going to derive it. So I'll say this yes can be now replaced by yes, and this is replaced by small a and star. And now again, we have only one non-terminal from the right side. So this yes can be further divided into yes less, which means from this production. Okay, so this S is replaced by this, and the remaining rest of the thing I am writing as it is. The objective is I want this as an output string, that accordingly I have to choose the right production from this three options. So three productions are there. From this three production, I have to choose the right production which help us to derive this. So now, according to the output string I want, now which yes I can derive the rightmost is this one. So this S as it is, then A, then the remaining as it is. Then the rightmost is the last one, this yes. So that is again replaced. So I'll get the final string which I want to get it. So this is called rightmost derivation from, which means from the right side, I'm taking the non-terminal, I'm deriving it. So that's why rightmost derivation. This is leftmost derivation. What is leftmost? From the left side, I'm starting deriving. So that's what the meaning of rightmost derivation and leftmost derivation. Hope you got it. We know that there are two types of parsing: top-down parsing and bottom-up parsing. This usually we are not using because it is inefficient. And in the example, top-down parsing on example is LL parser. There are many kind of LL parser we will be discussing in other videos. So here, recursive descendant parser, predictive parser, these are all example of this top-down parsing. For bottom-up parsing, we call it as LR parsing. The examples are SLR, LALR, CLR. So these are all examples of LR parsing, which is a bottom-up parsing. So what is LAL parsing? It is an example of top-down parsing. Top-down parsing means what? It starts from the root node and then it will go step by expanding it step by step until we receive the final output strings. So what is LR parsing? It is a bottom-up parsing. So what does it do? It starts from the strings. For example, it starts from the string. So how will you do this for a top-down parser? So for top-down parser, we started from the root node and then we arrived to the output string, right? Same thing if I want to do with the bottom-up parser means first I have to write the output string. So for example, A means A star. This is what the output string which I want. So this is what from the bottom, right? So how will I write? I'll write A plus A star. So I'm going to start from the bottom. So what will I do? Either you, since it is, so what I can do is I can start, I can write this A into S, right? And then I can again convert this A also as yes. And again, I can write what yes plus yes, or I can also write this also yes. And then yes plus, so I'll write yes plus together as yes. And then yes star, yes, yes star. So yes star together we can write yes. So from the string I came to the root node, right? So this is bottom-up parsing. Hope you can understand. This is top-down parsing. From the root node, I came to the string. What is bottom? From the output string, I came to the root node. This is bottom-up parsing. So for the example for bottom-up parsing is LR parsing. So these are the example algorithms present in this bottom-up parsing. I hope you have understood all these things. So types and what it means. So top-down parsing means example is LL parsing, which means it will scan the input from left to right, and then it will solve it by leftmost derivation like this. Same thing, the parsing. The importance is to check the errors, syntax errors. So in bottom-up parsing, what does it do? It scans from left to right, but the derivation it's do from the rightmost, but in the reverse order, since it is going from the bottom to the up. Right. Now, how to represent a grammar? Already I told the rules of a particular programming language is represented in the form of context-free grammar. So these are some of the examples of a context-free grammar. So here E represents an expression, T represents a term, and F represents a factor, which means if I want to write A equal to A plus B, or even I can write it as, say for example, if followed by you have an expression, followed by I have a statement, and then I have else. So then I have a statement, right? So how an expression should look like. So here I have the rule for it. So how a statement to look like, maybe a term. So how does it look like? So I have written here. So this is a programming language. For this, I have written a rules. How should it look like? So that is what the grammar is, right? Okay. And what is represented here is, for example, LR grammar. What is LR grammar? Means LR means I told it is one of the algorithm used in the bottom-up approach. Whenever I do bottom-up approach or solving, so here there should not be there should not be any non left recursion. So sorry, for the bottom up parsing, we don't want to check whether it is left recursion or not. But if you do a top down parsing, we have to check whether it is a left recursive or not. So I'll put a separate video about what is left recursion is. So for example, what is left recursion is, you consider there's a grammar E tends to E plus T. So here the left side is E, the non-terminal. Same thing, it is starting, the right side production is also starting with the same symbol, means it is a left recursion. For example, if I say T tends to T into F. So the left side non-terminal is equal to the first right side non-terminal. So if both are same, then it is a left recursion. So here we have lot of left recursion. So if you want to do any of the algorithm based on top-down parsing means LL parsers, right? So in that case, we have to remove it. How to remove this, I'll teach you in the video. Okay. So now we understood parsing is the parsing's main purpose is to identify if there is any error or not. So if it finds some error, what does it do? There are two error handling methods are there. One is panic mode, other one is parse level recovery. So using these two strategies, it will help handle the errors. So here are some of the common error handling methods. So first one is common errors occurs in different levels of compiler. So here in lexical error. So whenever there is a misspellings of identifiers, keywords, this and all the lexical errors. And what is syntax error? So whenever it is violating the rules of a particular programming language, then it is called a syntax error. For example, if I say, so the example for lexical error is, for example, instead of saying if and then expression, if I write this as fi and then expression, this is a spelling mistake, right? This kind of error may occur in the lexical error. So if it is in this manner, then it is difficult for me to identify that if is a keyword, right? It cannot find whether this fi is a identifier or a keyword. So that kind of error may occur during lexical error. What is syntax error? For example, instead of saying A equal to B plus C, then I have to put a semicolon in a programming language like C, C++, Java. So if I am missing semicolon, that is a syntactic error. And for example, I'm having a function, and in the function, if I am starting open curly brace and I'm forgetting to put the close curly brace, then this is also an error. So this kind of error are these are all a syntax error. Semantic error. What is semantic error? For example, I have a equal to 5 plus 50.71. So this cannot be done. So 5 is an integer, 50.71 is a floating. So I have to make both of them to a same kind of data types. So I have to convert 5 also into 5.0. Then I will do the addition with 50.71. So this kind of meaningful or logical checkings can be done in the semantic errors. So this kind of error is semantic error. And logical errors. What is logical error? For example, I want to check whether I have A equal to 5 and I have B equal to 10. I have to check whether both are equal or not. So I have to say A equal to B. So instead of saying equal to equal to, if I say A equal to B, then it is logically wrong, right? So this kind of errors are all logical errors. So this kind of errors are there. So this and all can be found out. So so what is the main goal of this error handler is it has to report the error. When it is reporting the error should be clearly mentioned so that we can correct it. And it has to recover from the error quickly so that we can avoid the other and so that we can able to find the subsequent error as well. And whenever we are doing this, whenever we are handling this error, we should not increase the complexity of that as well. So we have to minimize the overhead of this process. So if we are increasing the complexity, it will slow down the process. So whenever we do error handling, we have to keep all this in mind. So we have to properly report the error, and we have to quickly find out the error so that we can able to detect the other errors. And whenever we are doing this process, we should minimize the complexity, that is minimize the overhead so that it will quicken the process. Okay. So what are the error recovery strategies available? The first one is panic mode recovery. So what is panic mode recovery means? So it will discard one symbols at a time. What is one symbols? For example, I say A plus C, right? If right, for example, I'll say X equal to like that. So if I say X equal to A plus is there. So this is a error somehow. So what does it do? Either it will discard one symbol at a time, and then it will check will it become a meaningful one. So if it is open curly brace, and if it is missing the closed curly brace, so it will discard one input at a time, and then it will find it could able to recover from that. So this is a simple method. What is phrase level recovery means? It will replace or it will delete or insert one symbol at a time, and then it will try to recover. So for example, in this case, one particular variable or an identifier is missing. So it will try to insert one, and then it will try to recover from it. So, or it could able to delete one and then it will recover, or try to replace it with some other. For in the case of this, for example, if instead of writing IF, if I write FI, so it will try to replace and then it will correct it. And what is error protection means? If we could, for example, all the errors are checked through the context-free grammar, like grammars, like as I told, S equal to S plus I. This is an example protection. So if this is a kind of protection, so if this is a rule, right? So whenever it is trying to find any error, it will check whether it is following this rule or not. So if it couldn't able to follow this rule, it couldn't able to recover from that, then what does it do means it will add one particular protection to this rule, and then it will check whether it could be able to find out the error. So that is what error protections. It will augment one the grammar protection, and then it will check whether it could be able to recover from it. The other one is global correction. So this method is very costly, too costly. So usually this is not happen. And what happened in the global correction is, for example, we give a input string X and it is matched with the grammar G, and it is finding, it found out there is a problem and it couldn't able to recover. So what does it do means, it will create another string Y, and then it will try to bring this X, which could match to Y. So it will try to transform X to the form of Y. By that, it could able to solve the error. So equivalent to X, it could able to make a Y. And then try to bring X, transform X to Y. So by that, it will try to solve the problem. So this will take much time, and it is also too costly. So these are all the error recovery strategy, how we can able to recover from the error when it is finding any syntax error during this phase. So already I told you what is a context-free grammar means. It is a rule of a particular programming language which can be in a form of. So for example, if it is an if statement, what is the rule? How does it look like? So if followed by parenthesis, then there will be an expression followed by a statement, then there is an else followed by a statement. So if I want to write a context-free grammar for an if statement, this is how it's look like. So this is how we have written a production in the context-free grammar. So what are the rules or the definition of this context-free grammar? So for a context-free grammar, what are the things present in the context-free grammar? It has non-terminals, it has terminals, it has production, and it has a start symbol. So these are all the things present inside a context-free grammar. For example, if I say a grammar is S tends to S plus, or S tends to S into star, or A. So what are things present in this grammar? First one is non-terminal. Who are all the non-terminal here? Yes, this S is a non-terminal. This S, all this S are non-terminals. For example, if I say equal to E plus T, and then I say T equal to T into F, for example, I'm writing a context-free grammar like this. So here, who are all the non-terminals? This E, this T are all non-terminals. What is terminals? A. This A is a terminal, this star is a terminal, this plus is a terminal, which means this cannot be further derived. Plus, this is a terminal, star is a terminal, which means I cannot further replace this plus, star, or A with any other thing. And what is production? P is production. Production means, for example, S tends to S into S. So this is a production. Then S tends to S, S plus. This is a production. E tends to E plus T. So this is a production. And what is the start symbol? So in this case, S is a start symbol. So these are all the components present inside a grammar. For any grammar, for example, you consider here we have shown a grammar, right? So this is a context-free grammar. So if we see in this context-free grammar, who is the starting symbol of this grammar is E. So E is the starting symbol. So whenever I start a top-down approach, so I'll start from E and then only I come to the output string. So that is what start symbol. So these things are all the components present inside a context-free grammar. And a production will be in the form of this. So now let us discuss what is a terminal means, what is a non-terminal, how does it look like. So terminal are basic symbols. So as I said in the previous productions, A is a terminal. So this A cannot be further replaced with anything else because this is the leaf. Further, it cannot be replaced by anything. Plus, then a star. So usually terminals will be this usually represented in the form of small letters. And what is non-terminals? So for example, which can be further derived. For example, if I write production for a if statement, so if statement will be looking like this, right? If followed by expression. If this is true, then I'll go write another statement. Else, I'll write another statement. So if you see here, this statement can be replaced with another one value, right? And this else, this cannot be replaced with anything else. So this is a terminal and this is a non-terminal because it cannot be terminated at that. It cannot end there because it will be further derived into any other thing. So if is a terminal because further it cannot be derived into anything. If is always if only. but expression is non-terminal because this can be further derived. So I hope now you can understand. So this statement is also non-terminal. So further it can be derived. I have to say what statement is. So that is what non-terminal is. And so here a statement, expression are all non-terminals. So, and you know what is a start symbol. So for if I want to write this, who is starting or it starts with here. So always we have a start symbol. So from which it will be starting. And production, these are all the productions. So here, these are all the productions. So production says the rules or the grammars of a particular programming language, which will be having the combinations of terminals and non-terminals. So production of a grammar specify the manner in which the terminals and non-terminals combine to form an output string. So here is an example for a grammar for arithmetic expression. Arithmetic expression means what? A equal to A plus B is a arithmetic expression. C equal to X into Y. This is an arithmetic expression. So if I want to write a rule for all this arithmetic expression, how will I write the rules is what expressed here. So an expression can be a expression plus term or expression minus term. So what can be a term? Term can be a term into a factor. What can be a term? Alone factor. What can be a factor? It is an identifier. Right? So I have written all type of combinations of rules. So from this rule, I can identify whether this string is correct or not. So if I want to check A equal to A plus B is, how will I find whether A equal to A plus B is correct? I'll check this. From this, I can understand. From this, I can either go for a top-down approach or I can go for a bottom-up approach. And then if, for example, if I am using a bottom-up approach, from this, if I could able to derive to the root, then it is a correct one, correct string, right? So likewise, I can able to find out. So what are the notations used for all these components of this grammar is? So already we know for a grammar, what are the components it has or notation it has? It has a non-terminal, it has a terminal. So here it was given, right? So it has a non-terminal, then it has a terminal, then it has a production, then it has a start symbol. So how does all this look like? So terminals can be usually represented in the form of small letters, or it has operators like plus, multiplication, division, modulo, all these are all the operators. These are all terminals. Numbers are all terminals. Punctuations are all terminals. And then what is non-terminals? Usually non-terminals will be represented in the form of capital letters. Or it can be in this form, lowercase italic letters. So these are all considered to be as non-terminals. This capital letter E can be a short form of this expression. T can be a short form of the term. So this can be written in this form. So instead of writing a very big word like expression, E can be represented as, expression can be represented as E. Term can be represented as T. So likewise, we will be writing the rules. Okay. So what is, so I hope you can understand what is grammar. It is a rule of a programming language. If we want to write that grammar, what are the notations used is terminal, not terminal, productions and a start symbol. So now let us discuss what is a derivation means. So actually what is derivation? For example, if you see here, if I want to generate a string, here we discuss A plus. So here we so this is called derivations. So from this production, I derive to this output string. So this is called derivation. So that's what explained here. So what is a derivation? So a sequence of replacement of non-terminal symbols is called a derivation. So what we did actually here, a sequence of non-terminals. See here, this capital S are non-terminals, right? So this is sequentially derived to bring the output string. So that is what called as derivation. So usually a production can be like this, and further it will be replaced until we get the output string. So here is our examples. If I want to get an output string parenthesis ID plus ID parenthesis means, so how will we derive from that production? This steps is called derivation. So as I told you, so for example, if I want to write it clearly, it starts from E to minus E. And then this E is replaced by this. And now what happened? This is minus. And now this E is replaced by E plus E. And this is according to the rule. And then minus. And then this E is now replaced by ID plus E remaining. Then ID plus, then this E is replaced by ID. So this steps we call it as derivation. Okay, and I have already told you when I do the derivation, I can do the derivation in two ways. One is leftmost derivation, deriving from the leftmost non-terminal, or deriving from the rightmost non-terminal. So if you are doing top-down approach, then we will be mostly using the leftmost derivation. We will be using leftmost derivation. If you are going bottom-up approach, that is LR parser, then we go for the rightmost approach. So if so these are the derivations. Here is the example given. So leftmost derivation means already I have given an example here, so you can go through this. So this is an example for rightmost derivation, and here is an example for leftmost derivation, which I have explained. So it comes under derivation. What are the different way we can derive and come to the outputs? And the next one is parse-free and derivations. Derivations means now you have to understand what is the purpose of parse-free. To identify this problem, the syntax, we convert this grammars into or in the derivations into a tree structure so that it will be easy for us to identify the errors. So that is the purpose of parse-free. So converting the derivation into tree graphical structure. So parse-free can be seen as a graphical representation. So what I wrote, no. So here I wrote E can be written as E minus, and this E can be written as parenthesis E. And then this E can be written as E plus E. And now again this E can be written as ID. And then, so this derivation, I can now bring it in a graphical structure. How will I bring it in the graphical structure? E can be derived into minus into E. And now this E can be derived into parenthesis E and close parenthesis. And now again this E can be again derived into three things. E plus E. And now this E can be now derived into ID, and this can be derived into ID. So what will be the output? Minus and open parenthesis followed by ID, and then I have a plus followed by ID, and then I have a close parenthesis. Finally, I got this string, output string, right? So when I put this derivation in a graphical form, this we call it as parse. Now, hope you got all the basics thing of parser. What is the purpose of parser? To find the errors in the sequence of tokens generated by the first phase of the compiler, that is lexical analyzer. Two importantly used type of parser is top-down and bottom-up. Top-down means that is our LL parsers. LL means it will scan the input from left to right, and then it will derive by leftmost non-terminals. What is the bottom-up parser? LR parser. It will scan the input from left to right, but it will do the rightmost derivation in reverse. So these things we already learned. And then, so to check this error, we have grammars. So grammars only tells the rules. So when how to write the grammar, non-terminal, terminal, production, start symbols will be there. And then we learned that what is a parse-tree means. Graphical representation of this derivation is a parse-tree. So hope you understood. Now, what does ambiguity means? For example, if I want to develop or bring this string from the grammar, if I have more than one way to bring this string from the given grammar, then it is ambiguous. This is called as ambiguous grammar. For example, I want to bring this so if you look at both the parse trees are bringing the same output. See, ID plus ID into ID. So here also ID plus ID into C, but you can see the difference. Here, first here in the first one, E is derived into E plus E. Okay, and then this is derived to ID, and this E is now divided into E into E. Then finally ID, ID. But the same thing can also be written with another production, E star E, and then this E can be again divided into three things. E plus E, now ID, and this one is ID. So I got here also ID plus ID into ID. Here also ID plus ID into ID. Output is same, but the syntax tree or the parse tree is different. This is ambiguous. To produce one output, if I have more than one solution, then it is ambiguous. So ambiguity should not be there actually whenever you do apply to the parsing, especially when we go for LL parsing. So what is LL parsing? Is a top-down parsing. When you go for top-down parsing, we should not have, the grammar should not have an ambiguity. The grammar should not have ambiguity, and the grammar should not have a left recursion, and the grammar should not have left factoring. These three things should not be there. So in the next video, I'm going to explain you. Now you understand what is ambiguity. In the next video, I'll explain how to avoid this ambiguity. So if I have two parsers, which one to choose to avoid the ambiguity? And how to remove the left recursion and how to remove the left factoring. What is the impact of this? So this same thing should not be there whenever we go for this LL parsing. What is LL parsing? It is a top-down parsing. What is top-down parsing? It is one kind of parser. So to help in the process of identifying the error. So if you see here also, this is also a grammar. And if I want to produce this expression, I have two ways to do the same thing. So this is ambiguous. Okay, ambiguous grammar. So these are all the basic things about syntax analysis. Hope you got it. If you have any doubt, you can go through this once again so that you will be clear in it. Thank you. God bless you.